I'm going to explain the forecasting technique, which is used to forecast different things, maybe the demand and supply, or um, any products like which we have today. What will be the expected demand or in the future? So we have a lot of methods for calculating the forecasting. So one method is exponential smooth method, and the forecast produce using exponential smoothing method are the weighted average of the past observations, with the weight decaying exponentially as the observation get older, right? So what does it mean? In other words, you can say the more recent observation, the higher the associated weight will be. Means that the recent data will be considered as more important as compared to the older data, right? In simple words, we can say the exponential smoothing method are a family of forecasting methods, and they are weighted average of the past observation to the forecast new value. And the idea is given more important to the recent value in the series. So thus in this case, the observation get older in time. The importance of these values get exponentially smaller. It means the latest value will be considered and have a more weightage. Now, it is used only one weighting parameter, which is known as alpha. So now I'm just going to explain about alpha. Actually, this value determines the degree of smoothing by changing how quickly the level component adjusts to the most recent data. So alpha value can be from 0 to 1, and this is also known as smoothing constant. So this is the formula and explanation of this. Uh, and like ft is a forecast demand for a particular time t, maybe 5 years, 6 years, 7 years, right? And alpha is a smoothing constant. Actual demand, like t is a 7 years and minus 1, right? So t minus 1 means 7 minus 1 is the 6 year, is the actual value or for the time t minus 1, right? And forecasting is t minus 1 is forecasting value for the t minus 1, and damping factor will be 1 minus alpha. So it is used only one weighting parameter, which is alpha, and this value determines the degree of smoothing by changing how quickly the level component adjusts to the most recent data. An alpha value can range from 0 to 1. Let's take an example of this. Why we use exponential smoothing method? It is most effective when the value of time series follow the gradual trend and display the seasonal behavior in which the value follow the repeated cyclical pattern and over a given number of time steps. So in this example that I'm using, alpha is equal to 40%, it means 0.4. So this is the solution of this. I'm just going to make it clear with the help of one example. All right. So look at this. We just jump to the Microsoft Excel, and now the question is how to find the forecast demand for the 7th year, for example. So in this case, what I'm going to do, if I want to calculate the forecast and forecast demand for the t plus one, right? Let's say t plus 1, the t is the time. So here time is the total for a 1 plus 1 for the second year. I want to calculate it, I need to use this formula, right? So how to use for the first year? We know the actual demand is there. For the we cannot forecast for the today's, right? Today we have already, right? So it means that what we can do, we can make this as equal to the same, right? 310 is there, and 310 we can find it here. Now put is equal to sign alpha of actual t 80, right? Actual demand. So alpha, how much alpha is there? I have chosen the point 4, means 0.4 is the alpha. So alpha mean a constant demand and always will be 0 to 1. I have just explained. So this is the constant demand here. So what I'm using here, click here. So it will remain the same for all the forecasting. So what I do, I'm just going to put a dollar sign so that it should be the constant variable. So this alpha multiply by 80. So 80 is what? 80 is the actual demand, right? So 80, I'm just going to calculate here what is the actual demand. So actual demand is here is a 365. So this is the actual demand, right? So we have this demand here, and after then what we can do, we can calculate and plus bracket open 1 minus alpha. Here we have to put a dollar sign, then multiply by FT. FT is the future forecast demand. So the forecast demand of the previous year, right? And here we have also taken the B4. I think the B4 it should be B3 because demand for actual demand for the previous year, forecast demand for the previous year. Because that we want to calculate the demand for the next year based upon the previous data we have, right? We want to calculate the demand, actual demand is here, right? So next we have here 310 same. If I drag this one to the till 7th point, so we find that 431, that will be the demand for the 7th year for particular product. So in this way we can calculate. So next, if we want to make this data in a line diagram, so what I can do, I can select this data and after then go to insert, and we have these charts. So lots of charts are available. Click on this, I'll be able to see all these. So this is what we have, right? So this is a manually that we have calculated. And one more example that I can give you related to this, and look at this. This is the example number 2. I have put some data over here, and there is some demand for this. Okay, I'm just going to enlarge a little bit to show you clearly. Okay, so what is the weight? So weight is just 20% of the weight. It means 20% of the weightage of the actual demand we had in the last period or last time. Alpha is exactly if it 20%, this is the alpha is a, so one of the same thing. 0.2 is the alpha. Alpha means constant demand. As I explained, it should be from 0 to 1. Now damping factor is another factor, means if alpha is 20% and damping factor will be 80%, means the 1 minus alpha. And we know that in the first beginning of the period, forecast demand. So forecast demand will be exactly the same as the actual demand. So I'm just putting it here like this. Now I'm just going to start. I want to know how much will be the demand in the month of December. So we have the actual demands from January to November. So let's say start with is equal to sign, and starting with one thing, that is alpha. How much is alpha? We have not decided. Yeah, we have decided here 20%. So 20% alpha is here. So as per the formula we know is equal to 20%, right? So this one alpha is 2. So this is a fixed, we are not going to change it, right? Multiply by demand, right? So actual demand, then plus bracket open, we have here 1 minus alpha. Again that I need to put it here dollar sign, multiply by the forecasted demand of the previous year and enter. So we have 86 and same 86 here. If we drag a little bit down, then we will be able to find that in the month of December, demand of some product, maybe napkin or something, that will remain the same, is 86, right? So this is how we have calculated this much of demand here. So let's figure out whether that we have done it correctly. Let's see, double click here, and just for your convenience I just want to put some formula here. This is the formula, and I can put it here and just verify whether that we have put this formula correctly. So look at this B2. So this is what alpha 80 actual demand, right? So alpha is that we know this is the alpha here, and B7. So this is a B and 7. So B7 that we have here, okay, for the previous year plus 1 minus alpha. So alpha is the B again that we have here B dollar 2 and multiply by C7. So C7 here is what is the forecast demand of the previous year. So this is C and 7, right? So everything is right. I just have dragged it down and we have this data available.